tells an effective story. Pictures do. So a table of 10,000 number is meaningless to the human eye, and a single chart can reveal pattern, outliers, and trends that would take hours to find by staring the raw number. That's why visualization is a very important aspect of the data science. So, so I'll show you an example where we will have four. I'll show an example based on four identical statistical summary. That is, it will have same mean, same variance, same correlationship, same regression line, but when you plot them, they look completely different, and that's why we visualize. So here I have four different data set: one data set, two data set, three data set, and the fourth data set. And here, and all these data set have same around same mean, median, mode. But if we try to visualize it, definitely the pattern is completely different. So that's why we visualize to data set to see if how's the pattern. So in So when do we use visualization? You will use visualization in three contexts throughout your data science career. EDA, that is exploratory data analysis, in order to understand your data before modeling. Uh, how your data is structured, where is the data concentrated, uh, the data distribution, and in order to understand the data, you plot histogram, scatter plot, box plot in order to have a better understanding. And so, in the context of EDA, it is very powerful tool. And then, in terms of communication, when we want to present our finding to stakeholder, the stakeholder are not interested in individual data point. In some cases, of course, they might if the data point is of interest, but if there are 10,000s of rows of data, then it is not possible for individual to go and analyze the individual data point. So in that at that those time when we need to communicate about the data, then the visualization charts like bar chart, line trends, and dashboards help in order to communicate our finding. And also during the debugging, when we want to debug, that is when we want to verify our model, our trained model, or during the after the training or during the training, the residual plot and the loss curve can can understand the training weight, how the weight is this how the weight is determ- is decided or for the different variable, or how the loss value is for the test data set. So if you have 20% of test data set, then you can use the visualization tool like loss curves and all to visualize the your model efficiency. So as I already discussed, that Matplotlib and the Seaborn are about those two library we are going to discuss, and these library the from among these, the Matplotlib is the foundation. You can say the Matplotlib is the grandfather of Python visualization. Why? Because almost every other plotting library Seaborn, Plotty, even Pandas have built-in plots, and it builds on top of Matplotlib. So it gives, and why? So what Matplotlib gives, apart from just standard visualization, it gives us the complete control over every pixel of our chart. Uh, but that control comes with verbosity. So you can think the Matplotlib as a Photoshop, incredibly powerful, but you need to learn many commands. So Matplotlib is very powerful with a lot of customization possible, but also there are a lot of things to remember, and that's why this Seaborn is much more preferred when we want the standard visualization. We don't when we don't want much customization. So in that case, we use Seaborn. Yes. So here we are going to import three library: Matplotlib, Seaborn, NumPy, and Pandas. And so what are we going to do? We are going to first import these library. These are the so among these, this is the only library which is responsible for plotting. NumPy, we have already discussed, it is the for numerical computation for either random data set generation or matrix transformation computation related thing. This library is responsible. Pandas is for data transformation, data loading, data filtering, and all those kind of things. So here, this is the absolute simplest plot. Here, we provide the x coordinate data and the respective y coordinate data, and we ask plot to show, and plot is is pie plot. So so this is the simplest form of visualization. So here, the these two lines of code, the plt.plot, and plt is the import from matplotlib pyplot. So it is pyplot, and pyplot.plot is the only thing which is required for plotting the chart, and dot show is enable us to final for the final visualization to be displayed in the interface. And now this works, but it is very ugly and meaningless without context. So a chart without much of information, just with a line or with number, is very hard to interpret what it is saying without proper labeling. So let's add proper label and some style. So here the data set we have separated: the x-axis data set, the y-axis data set, and we are setting the figure size. What should be the figure size in inches, and then we are plotting. We are setting, configuring the color of plot as well, the width of the line, and whether to show the marker for the data point where the x and y is lying. So that should be shown. So marker equals to this enable set, the overall title of the plot, x-axis label, y-axis label, whether to show the grid line. So grid line is very helpful thing in order to interpret where the if you want to determine what the x and y value of a point in the graph. So this grid makes it possible. So here now we can see, you can see now the plot has increased in size because of we have set figure size as 8 by 5 inches. We have set color, we have changed the color of plot as steel blue. We have increased the line width and we have set marker equals to uh, O. We have put O over there so that it shows a dot, and marker option you can uh, if you don't put it, then it won't show any marker. So if you put O, then it shows a marker at each point at XY. Title, the title of the chart, the X label, the Y label, and whether to enable the grid. And tight layout prevents label clipping. So sometime the label might get clipped. So it makes sure the tight label layout, if you do, then it makes sure that everything is visible and nothing gets clipped off. So every plot you create should have a title, axis labels, and appropriate sizing. A chart without label is like a map without a legend, which is useless. So before we dive into chart types, let's understand how Matplotlib organize things. So there are two key objects. The figure is the overall window page. Think of it as the canvas of the entire piece of the paper. The axis, and by axis I'm not saying axis, but axis is an individual plot within that figure. A figure can contain one or many axes. And when you call plt.plot, you are using the pyplot shortcut that auto creates a figure with one axis. When you need more control, especially multiple subplot, you use the explicit figure and x axis approach. So we will see that. So this is the what we saw was the method one, and that was the pyplot interface for quick and simple, best for single plot. So So this is what we saw, figure, and we are calling plot and the title, and then show the simple approach. And now let's say if we want to have subplot. So in that case, we will call subplot. So it will give access to us figure and access, and then we will use access to create the plot. So here the the difference is that we use this kind of approach, the second approach, when we in single figure we want to show multiple plots. Let me show you an example. So this example, in fact, in the same see here in the same example, we are creating 2 by 2 plot. So total four plots will be shown in one figure. So in one go, rather than having an individual plot, if you want to have mini subplot, then what we do is we call subplot and define how many how many rows and columns of plot of graph we need. So here 2 by 2, so total four, two rows and two column, and then we get access to figure and axis, and then we can use the axis for plotting x dot plot or particular plot method, for example scatter plot, and then we can set title, and then at last we can set overall figure properties, like we can set the title of the overall figure, and then we can ask plt.show. So figure is the overall outer area. These individual plot we can access and have data set to it, and we can plot individually, and at the last we can call plt.show to visualize all of the all of the plots. So now let's g- get into in a different kind. Let's see different kind of plots. Line plots. So line plots shows trends over time. Let me write it. So what are the line plots? Line plots shows trends over time of time or continuous data. So uh, for example, let's say temperature over time, or stock market price, or trend, for example, revenue over time. So for these kind of data where time or continuous data set is there, the go-to chart is where the x-axis is sequential. We use line plots. So by sequential we mean date, month, year, time step, and so on. And the line connecting the point implies that the data change smoothly between the measurement. When to use? Time series data, for example, stock price, temperature over months. Continuous measurement, speed over distance, comparing trends between groups. So let's see the basic line plot. So let's say we have a data set of month and sales. So month will be our x-axis x-axis data set, and sales are our y-axis data set. So we are passing month and sales in plt dot plot. It accepts either your pandas data frame, or you can pass individual series data set or list of values of x and y. So here this is directly, for example, the data structure is structured in such a way that for January 12,000 value, February 15,000, March 13,500, April 16,000. So in this way, the data is related and is passed to plot. Plot color, we are setting line width, marker size. We are configuring all everything related with marker. We have set title to the plot, overall plot, with the font size as 16, bold text and padding. Padding gives a gap around the title. So that means the main area where the chart gets plotted, there will be a padding of 15. And X label, Y label. Here, here we are using annotate method. So annotate method can be used to put a text at the chart. So here what we are exactly doing is, first let me show you without the annotation. So this will show us the regular our time series plot, that is monthly sales data. Let's say we want to annotate the peak. In here, the peak is over here. But let's say if the peak would have been somewhere in middle or somewhere else, and then the drop would have been there. In fact, we can do that as well. 2023. So let's say this is the peak, and now we want to annotate that. So in order to that, first we need to find the maximum of sale. So from that, so max of sales. Max is a Python method which returns the maximum value from the list. Sales is our list. So here we will get the value, and then we are getting sales index for the value. So for the maximum value of sale, we are getting index of this. So we'll get index of maximum value. And then we are using Matplotlib annotate. Here we are formatting the text like peak, max of sales. So the value will be printed here where where the where the data is annotated. For the XY, we are passing, we are getting months index based on the max index. So basically here we know that max of sales is this. We are getting index of this. Why we got index for this? Because if we know the index of the maximum sales, for example here, this is the maximum sale, and if we are able to find the index, then the same index, corresponding index for month also we can get. If we get the corresponding month index and month, then from that we can get the month value. So here we are doing that only. Here we are getting months value based on the max index and max value based on the based on the max of sales. So with that, we will get the XY as this point. And where the text should be printed, what we are doing is we are going to print it a little bit on the left to based on the position of previous two index, because we are doing max index minus 2 and max sales plus 1500, so it will shift the value upward. So from the month's perspective, it will the text will appear over here and bit above. uh, so here, but now it is going out of the chart, so rather than plus 1500, we can do minus 1500, and we can rather than minus 2, we can do minus 3. So in this way, first the data was selected, and where the text should appear, we specified using xy text. We are putting on this as the we are taking this as the x-axis, and for the y-axis, we are taking the maximum sales, whatever the value is there, we are putting minus 1500 value. So it is going to be a bit below than this. And then this is how we create the annotation. So annotation is very important for labeling the important data point. And the line chart, we can use multiple line chart at once for comparison. So here I'm plotting three plots together for three team. So months will remain same, but individual teams performance will vary. So based on that, you can see that task completed for individual team is shown separately. So in this way, we can use a line chart for comparison as well. So these are the key parameter for plt.plot. We can set the color, line width, line size, marker. So the marker can be, we can specify the shape. So here you can see that we have specified different shape of the marker. In here, in the first, we are showing dot as a marker. In second, team 2, team B, we are showing S puts a square, and for the third team, team gamma, by putting this hat keyword, gives a triangle. And in this way, we can show different points shape. Marker size we can set marker face color, marker edge color, alpha, and label. Alpha is the transparency of the line, how translucent or opaque we want. So now let's look at into the bar chart. So bar chart is a way for categorical comparison. So let me first put this. So bar charts are the workhorse for categorical comparison. We use them when your x-axis has discrete categorical categories like cities, department, products, and your y-axis has numerical value. For example, count, revenue, average. So one of the example of bar chart is GDP, country's GDP. So individual country can be a bar, and the height of bar can be determined by the value of the GDP for that country. So, so, so this is bar chart are very useful when we want to compare multiple categories, a value of multiple categories or across, uh, or we if you want to show ranking. So now let's see the vertical bar chart and the horizontal bar chart. So here in our previous example, in all of our previous example, we were plotting our bar. We are plotting plot. We were calling plot method to plot the line plot. But now in order to plot the bar plot, we call plt.bar, and bar also accepts the x data set and the y data set, the corresponding y data set here. But the x data set is category rather than the ca- integer value. In our all previous example, we had on the x-axis either month name, which were or maybe or an integer value. So the everything were a kind of continuous data set. Um, in this, for example, monthly sales data set, here, although individual month data set was taken into consideration, but here February followed January. So February was a continuation of January, March was a continuation of February, and so on. So there was the growing trend. But when we are talking about categorical data set, each category is independent. So here, for example, the department headcount, we have category of department and headcount as the y data, and we pass those data and call the bar method. So this we are using to add value label on top of the bar. So if we don't use this, so you can see that we can see the bar plot, but here what is the exact value of each department is very hard to find. So we have to guess it. So better that we visualize it. In order to visualize it, what are we going to do? we are going to iterate each bar, and we are going to add text based on the bars x bars x value. So here the x value for this will be this point data, for this here, for this here, the x value will be, you are getting right, the starting point of the bar. So here for the text we are going to provide x and y coordinate. So in order to find the x, what we are going to do, we are, for each bar we are iterating over all the bars, and the bars are the value returned when we called plt.bar. We are iterating over the bar, and for each bar we are putting the text at the start of the bar plus half of the width of the bar. So that means at the center of the bar, because bar plus width will give us at the end of the bar, but we don't want to put at the end of the bar, but at the center. So bar dot get x plus bar dot get width divide by 2. So at the center of the bar, and at the y location where bar dot get height, it will give us the this thing plus 0.5. So it will write just above the bar. So if we do that, we get the text as we can put the text, and the value will be the head count value. So for each bar. So in this way, we can show the vertical bar. Similarly, we can show horizontal bar chart when, so here when the label for the each bar is long, then you can use the horizontal bar chart, because in vertical bar chart either you will have to write the uh, if you want to write some text for each bar, then you will have to horizontally write it, or else you can use horizontal bar chart, which is very easy to write the long text as well. And then we have grouped bar chart. So here, when two related, so let's say if we have under each category we have subcategory, and we want to group, so in a way, we if we want to show the subcategory data set also, so in that case we use grouped bar chart. And here, so let's say q1, q2, q3, q4 are our category, and we want to group them. So in a way, we if we want to show the subcategory data set also, so in that case we use grouped bar chart. And here, so let's say q1, q2, q3, q4 are our category, and we want to group them. So in a way, we if we want to show the subcategory data set also, so in that case we use grouped bar chart. And here, so let's say And inside that, let's say we have two products, product A and product B, and we have individual data set rather than a merged data set for all the product for community product. We have the split data set for product A and for product B. Now we can show the in comparative bar graph for product A and product B as well. Rather than just only Q1 Q2 comparison, we can have Q1 Q2 comparison as well as the individual product revenue comparison. So here, so for the for that thing, in order to achieve, we need to have the split data set for the subcategory, and then we will use subplot, and in that we won't provide uh, rows and column. We are creating subplot in order to just get the access access to the access interface, and then here we are going to create two bar chart in the same access, in the same subplot. How we are going to distinguish the two? Only by giving the giving the x location of bar 1 as x minus width by 2. So the first width will be uh, first half of the total total bar will be taken by product A category, and the second half of the bar will be taken by product B. So in this way, we are plotting the two bar, and then we are setting the label and all, and then we are adding value on top of the bar like how we did in our previous plot.
Hello, sir.
Yes, yeah, go ahead.
Sir, due to some reason, I have lagging my project. So I just want to ask that in the, I mean, in the data science, in do it yourself, I have doing my code in Google Colab, not in Spider. Due to some reason, I can't unable to downloading the Spider in my system. So I'm doing all the codes in the Google Colab.
Okay.
So from that only I am uploading what are the codes I have in the do it yourself. So that it works, or else it makes any difference.
You are talking about the course or in just general for the learning purpose or overall practice, like what is the standard way of
No,
doing
no,
it?
I am talking about the course is what is running. So in the first, I mean, in the first data science. So in that there are the classes, and after that the questions are there, right? In the do
Right,
it yourself. So in that we need to upload the questions, right?
right. uh,
So
I think you can talk this thing regarding this thing with the project coordinator on the WhatsApp, because that person will guide you appropriately regarding this.
yeah, yeah.
Because
For that, I have
huh,
called, but no one is answering, and I have mailed also, but till I didn't get any replies from them.
when did you contacted them?
Today, I'll start contacted them from yesterday itself, but
Yes. Uh,
no
maybe
one is responding.
yeah. They definitely they will respond. Maybe it might be due to the workload, but you can expect in next couple of days that you might get the reply and get the clarification. And in fact, I will also forward this thing, the issue. what you are facing to them, and don't worry about that. And you can continue your work in Google Colab. There is no issue. And even if they ask that uh, they need file in let's say in they need source code in raw format, as in py format, then you can use your Visual Studio Code editor or any text editor. You can copy the content of that Jupyter notebook, and then paste it in it and save it as py. Spider is one of the id, and it is not something which is a standard way of doing it. There is no from the terms of the from the tool of coding, there is no such thing as a standard. And yeah, Jupyter notebook and the Google Colab have become widely acceptable thing, and it is very good for sharing your code. You don't need to run anything on your machine. If you use Google Colab directly, you can you can test your code on the go on any machine, and you can even share the code. So I don't think any harm in using the Google Colab, and you can, in fact, you should focus on your coding part, and definitely they will update you regarding this thing. And if they say, and they shouldn't, the project manager won't say you to submit as a plain py code, but if they ask you, then there is no, I mean, it's not a big deal. You can copy paste your Google Colab code in your Visual Studio Code as a py file and then share it
But
across.
it doesn't make a lot of difference, right? I
Yeah,
mean,
yeah, it doesn't make a lot of difference. From practical coding perspective, if you're talking, of course it makes a difference. In production mode, if you're talking about, then you don't use the Jupyter notebook is for testing your idea. But when you are writing a software program, then at that time, definitely you need to have a py file, because your project consists of multiple files, and you create modules. And then in that case, you need to have a kind of pip system. Different, you would like to use virtual environment, and modules, you want to create your own modules. So in that case, definitely a kind of ID like Spider or Visual Studio Code or PyCharm or any kind of ID, in that case will be required, because it won't be just a snippet of code, but it will be full-fledged file-based code. So in that case, but in
that's
for your project base, I don't think so. It should have an effect. It would cause any issue. But you should get the confirmation regarding that.
okay, sir. Okay, thank you.
Okay, you're welcome. So now let's quickly look into stacked bar chart. It is also one good way to communicate the visualization when particular, for example, when we want, let's say, a bar to communicate its individual component. For example, let's say here each quarter revenue, how the revenue, what revenue was, and for each quarter it is made up of what. For example, here yellow denotes offline component, and blue represent online component. So in this way, you can see the proportion. So this give one more depth to uh, your data set, your individual bar. So for in order to achieve this thing, we we plot two bar, one with the quarter and online data, and the second with the offline data. And for the offline data, we are setting the bottom as online. So in this way, it gets stacked. If we don't specify, then this part bottom equal to online, then it won't stack. It will be on top of it. orange will be on top of blue, and we don't want that. Because why we don't want that? Because this data set is cumulative. Q1 data set, what we want to show is cumulative. So we want Q1 to be 15 plus 10, 25, not only 15, because total sale is 25, out of which 15 is online, and 10 is offline. So that's why we want stacked. And in order to stack it, we specify for second yellow bar, put it at the bottom of online and online data set. So in this way, it gets stacked. And now Q1 is cumulative of online and offline. So this is also a very powerful tool of uh, communication, data communication, when we want to split the category. So now next powerful kind of plot is scatter plot. So here, so scatter plot is used to visualize the relationship between two variables, and it is uh, it is a very good tool to see the regression, and visualize the regression as well. The pattern of point reveals whether there is a positive correlation between the two two variables, or negative correlation, or no correlation, that is random scatter. So this is very most important. This is the most important plot type in data science, because it directly visualizes the relationship between two variables. And when we use it, when we want to explore the relationship, whenever the question of relationship between two variables occur, scatter plot is a go-to plot. Always remember this, when we want to show relationship between two variables. So we find correlationship, spotting outlier, and checking linearity before regression. So this is also very important, because when we can see see the regression pattern in the data visually using the scatter plot. That is where the relationship between two variable is leading, where will the future point will land. So let's see how to visualize it. So here, in our previous box plot, we used plt dot box, and here before that we were using plt, sorry, not box, bar. We used bar in our previous example, and before that we used p plot method in order to plot the linear plot and the bar plot. Scatter method we use in order to draw the scatter plot. So here, let's say r is one variable and the score is the another variable. So let's say if there is a correlation between the hours of study, the student study in terms of hour versus the score. So let's say if we have that data set, and now we want to establish the correlation, then we use scatter plot for that. Let's first disable the trend line, and we are adding the standard title, X label, Y label, and the legend. So here, and of course, this data set is the synthetic data set. This is not true data set. So here we can see that there is a pattern over here. What do I mean by pattern? By pattern here, I mean that as R is increasing, the exam score is increasing. You can see it is an upward, there is an upward trend. So we can say there is a positive correlation between R and exam score. We can say that as put more hours into studies, the exam score increases. And based on these data set, we can plot a regression line also. And we can use the regression line. If we know the student study hour, then we can use the regression line to find the pro- probable exam score for that student. So let's first add trend line. The trend line is a line which tries to fit all the data points into it. So it will try to adjust so that it is equally it it adjusts itself and lies at equal distance between all the points. So for that we will use polyfit and numpy's method polyfit, which will, so here this is a way to find the linear regression. Polyfit calculates the linear regression for these two data set, R's and score. C represents the line which will fit among this scatter plot, and then we are converting we are getting we are then getting the poly id, the one d value for that nd array, which converts into nd array, and then we are determining the x line data set. We are generating 100 data points between the minimum r and the maximum r. So we are taking the minimum r's from our data set and the maximum r's from our data set, and we are generating 100 data points, and we are plotting that x line. And for the y data set, we are using p for x line. In this way we get the regress line. So we mathematically, we using numpy, we calculated the regression data set, and we plotted it using the matplotlib, using the data set x line and p x line. We are plotting it. So here we can, we can add more dimension to our scatter plot. So here the relation the so here we call it as bubble chart, which is also a scatter chart. But here the size and color also have, we are adding more depth to the chart of the scatter plot. Here size as the value, here the value of the category, for example. So here, if you look at the legend, so here the yes, over here on this line, population the three. If you look at here, the size of the circle is determined by the population of the of the particular continent. So here we have GDP, life expectancy, and the size is what the population of the continent is, and the color represents the continent. So here we are giving more depth to the information. That is, so here histogram plot. This is also one of the very important plot. Histogram shows the distribution of single numerical variable. So if you want to know the frequency value, how it occurs across different ranges, we use histogram. Histogram answers the question how and what does my data look like. If it is bell shaped means that it is normally distributed, skewed, or it has bimodal or multimodal histogram. So when we have bimodal or multimodal, then that means that we have the ranges, multiple ranges in the data set. We can uh, split the data set based on the peaks. So it is very helpful. Histogram is very helpful to determine the if there is a pattern in the data set. So histogram is the first plot you should make when exploring any numerical column. And when we use the histogram to understand the distribution and shape of the data, finding the most common ranges, spotting skewness, outliers, and the gap, and checking if data is distributed data set, or is it bimodal or multimodal. So this is very powerful, and let's see how to use the. So here we can use plt.histogram, and here since we are only using one variable, so we are going to pass only that one variable. Here we are going to pass, for example, ages, and it will generate the distribution of age variable. Here the frequency is for the bin. So for example, let's say this range starts from 20, and this is, let's say, from 20 to 22, for example, let's say. So for 20 to 22, how many data points are there in the data set? So let's say if this is 38, so we can say the 38 data set are in the range of 20 and 22. Here, let's say 40 and 42. So between 40 and 42, there are 82 data sets. So this is how uh, the data distribution is shown. Here, each bin size can be customized using the number of bin property in here. Here, if we increase the bin size, then it will become too thin, and uh, then it totally depends if we might, if we don't have the, let's say, median, then in that case we will miss where the original, makes it hard for us to visualize where the peak is, in order to find the uh, central distribution. So we have to keep the bin count effectively so that it is not neither too thin or too wide. So for example, if we go too thin, for example, if so too wide, that is if we keep bin as 10, so it abstracts away the data distribution. It doesn't give much detail. So the good data bin is around 30. It gives a lot of information without. So here you from if you keep the bin as 30, then you can visualize, okay, this is bimodal, unimodal, and only one peak is there. You can consider this thing as only one peak. But if you increase the same thing into 1000 or maybe 100 bin, so here it makes decision whether this thing should be considered as separate peak and this as a separate peak, this as a separate peak. So a higher bin can add confusion, lower bin can abstract away the information, better is at around 30. So, and what exactly is bin? Bin is your data range divided by the number of bin. So, it represents, then based on the bin, determines your width of each bar. So, if the range is between 0 and 75 and the bin is 30, so that means the range is 75, and each bin size will be 2.5 point wide. So here each bin is 2.5 wide. So bin tells that how many buckets needs to be created between your data range. So between 0 and 70, 30 bins were created. So each bin is around 22.5 width. So histogram is another important uh, visualization tool to see the distribution of the data set. And then we can have overlapping data histogram. So it is very effective if we want to compare two categorical data distribution. For example, pink refers to the female and blue refers to the male, and this is the overlapping, and we are comparing the height distribution by gender. So this is the overall height distribution for the female, this is for the male. So in this way we can compare, and from this we can see that uh, female generally tend to be shorter than the male. From this, it is how much it is comparable. We are able to see how what is the percentage of common group of similar height of female and male. We can see a pattern over here. So around 50% of female, more than 50% of female share a common percentage of height distribution about the lower height segment of male. So it is very effective way to visualize and communicate the uh, and this is a same explanation about bin. 5 bin too few, it abstracts away the information. 100 bins too many, it gives a confusion whether individual peak should be considered as a separate thing. 30 bins is a perfect because it gives a unique peak, and we can see a pattern that it is a normally distributed. And so then we have the pie chart. which is very standard way to communicate the categorical data in terms of percentage. So pie chart shows proportion of whole. When we have 3 to 5 categories and want to show percentage breakdown, however, pie charts are controversial in data science. Many experts prefer bar chart because humans are bad at comparing angles. My advice: use pie chart for simple high level summaries, budget breakdown, market share, and bar chart for detailed comparison. So, so this is how uh, we can plot the pie chart, and do that we use plt.py in order to plot the pie chart. Here, it accepts the share and its label. So 22% share, what is label, 20% share, what is label. We are passing that share and its corresponding label. That is, in this case, it will be brand, and then we are configuring the text props and wedge props. How much, what the wedge color should be. So in this way, and the other similar to pie chart, we have donut chart. So here, and when we plot pi, we can set the so here we can set the edge color white, and this way we can create modern alternative to pi, that is donut chart. So we are now the next part, chart is very important, and it is called as box plot. So box plot, also called box and whisker plot, are a statistical visualization that shows 5 number at once. The minimum, the Q1, that is the 25th percentile, the median, that is the 50th percentile, the Q3, that is the 70th percentile, and maximum. So it is uh, very compact and powerful tool to see the data distribution, and the box represents the middle 50% of the data, which is called as the IQR, the interquartile range, and any point beyond the whisker are can be considered as a potential outlier. So this tool is widely used to determine the outlier. And always remember that IQR, outlier detection. We will. So here we haven't. Hmm. So in this we are going to use box plot in order to visualize the box plot. So here the box represents the 50% of the data. Here the the e- edge of the box represents the 25th percentile, the top as the 75th percentile. The whisker are called as the lower and upper bound, and which is calculated based on the 1 point, uh, the lower bound point minus 1.5 into the range of this, and the upper bound is calculated using the upper bound plus 1.5 times the range of this. So any data point outside this can be considered as an outlier. So, and initially I discussed about the subplot. So, in real time situation, real data analysis, we rarely use just one chart. We often need to show multiple chart at once. So we use the grid of different chart. So we can do that using the subplot. So we are going to see subplot. Here we create subplot, we get access, and we use access to configure individual chart. So in here we create a 2 by 2 subplot, and you accessed the access individual access to plot the line plot, bar graph, scatter plot, and histogram plot. So I'm going to end today's session, and so we looked into different types of visualization. I'm going to share the code so that everyone can review it, and so everyone will get this code in their email as well. So along with this video, you will get the link to this session as well. So have a nice weekend. Bye bye.